Hi, my name is Sahib, and I'm going to be presenting this paper right here for my presentation for bio of cancer. So the paper I'm presenting is called Exosomes Derived from Hepatocellular Carcinoma Cells Induce Sorafenib Resistance in Hepatocellular Carcinoma, both in vivo and in vitro. So this paper investigates liver cancer or hepatocellular carcinoma. It cites it as it being the fifth most common cancer and the second leading cause of cancer-related deaths worldwide. That's obviously a huge problem. What specifically interested me, piqued my interest about this paper was exosomes. It was interesting to see how exosomes would help in cancer development. In this case, through uh, allowing cells or helping cells develop a resistance against the drug that was used to treat cancer. So the drug over here, sorafenib, is actually, the paper cites that as it being the only drug. Sorafenib is currently the only medication approved for the treatment of liver cancer. So anything that would be building up a resistance to it or inhibiting it would be a huge problem. So the paper explores how these cells developed a resistance against sorafenib, and it cites that they induce sorafenib resistance in vitro by activating the HGF c-Met AKT signaling pathway and inhibiting sorafenib-induced apoptosis. So I'll be investigating specifically two figures that directly show this effect. So yeah, first we have to get the nomenclature though to understand specific things in the figures. So the researchers needed to derive exosomes from liver cancer cells because the paper says exosomes derived from liver cancer cells had to induce the sorafenib resistance. So they picked two strains of liver cancer and they called the exosomes derived from it MHCC 97H and MHCC 97L. So for simplification, I'll be referring to them as 97H and 97L exosomes, and they had different invasive potentials. Uh, and they also derived exosomes from non-invasive liver cells, so normal non-invasive liver cell line, and that's going to be called LO2. So 97L and 97H are the uh, cancer invasive exosomes, whereas the LO2 is a normal non-invasive liver cell exosomes. And remember, these are not the cells; these are going to be the exosomes. So the first figure I'm going to be presenting is an apoptosis assay right here. So an apoptosis assay, we've done this in class, but a brief overview. It examines the number of cells in apoptosis. So each one of these little dots is a cell, and depending on which quadrant it's in, it's going to be either apoptotic, non-apoptotic, or necrotic. So the these two quadrants right here, this one and this one, they are the cells indicating apoptosis. The top one is late apoptosis, the bottom one is early apoptosis. And this top left quadrant right here shows necrotic cells, cells in necrosis, and this quadrant right here shows cells that are alive and functioning well. So the way this assay is done is that it there's two substances, annexin 5, which binds to phosphatidylserine protein on the inside of cells. However, when it comes on the outside, annexin 5 binds to the phosphatidylserine, and on the bottom x-axis here you can see increased annexin 5 binding. So increased annexin 5 binding means cells would be in apoptosis, and that's why the increased side right here, and these two quadrants show the apoptotic cells. Especially this shows late apoptosis because there's also the DNA of the apoptotic cells binds to propidium iodine, which is propidium iodine binding levels are shown on the y-axis of the apoptosis assay. So as you go up, higher propidium iodine binding, and as you go up over here, it shows higher Nexin-5 binding. So that's the basic gist. So now we're gonna examine each of these. So the control didn't have any drug or any exosomes present in the sample, and remember, this is in vitro. So you can see there's a good amount, 91% actually healthy, normal living cells over here. So that's not out of character at all. But then as we go to this, the cells treated with sorafenib, we can see that a lot more apoptized, as you can see, a lot more in the late apoptosis stage, right over here, and that's normal because sorafenib, it actually induces apoptosis. That's how it inhibits or treats the liver cancer, by inducing apoptosis in cancer cells. But then when we go over here, this is also similar to this one. So when they input the regular normal liver cell line exosomes plus the sorafenib, you don't see much of a difference. Well, there's a slight difference, as you can see. There's less apoptosis because there's less cells in these two quadrants, this one and this one right here. So there's less apoptosis, but not a huge jump basically. But then when you go to the next apoptosis assay right here, which is treated with sorafenib and the 97L exosomes. Now, if you remember, the 97L exosomes were derived from the invasive hepatocellular carcinoma, or the invasive liver cancer. You can see there's a much bigger decrease compared to regular sorafenib and sorafenib plus the regular non-invasive, non-cancerous liver exosomes. There's a much bigger jump. So there's less apoptotic cells right now, as you can see over here. So even though the liver cell exosomes over here might have reduced the action of sorafenib a bit, the action of the 97L exosomes was to reduce it even more. That's why you see even less apoptotic cells. So sorafenib over here, a huge increase in apoptosis. Now what it's trying to show over here is that the exosomes, there's actually a decrease in the increase of apoptosis. So an overall decrease in apoptosis. That means the cancer cells aren't apoptizing, well, a lot of them aren't, and so the sorafenib is basically, there's some resistance to sorafenib, and that's due to the 97L exosomes. So 97L exosomes, less apoptosis, and more growth of cancer cells. As you can see over here, the 97H goes even farther. So if you saw 36% over here, there's a 25% over here. Compared to the 45%, you can see, so there's 45% apoptosis in this quadrant. This is late apoptosis, well, with the sorafenib, but it goes all the way down to 25% when you add the 97H exosomes, which were from the invasive liver cancer. So that just shows that the cells, they were the action of sorafenib was basically it was resisted or was reduced greatly. And you can, it also compares the 97H and 97L cell lines. The 97H decreased or inhibited the action of sorafenib even more. So now moving on, we'll show how basically, so the paper states in the beginning that the action of the induced sorafenib resistance in vitro by activating the HGF-c-Met AKT signaling pathway. So that's basically the PI3 kinase AKT pathway that we learned in class, and we'll be examining it through this figure. But the AKT signaling pathway, so first we'll go over here. So it cited it as the HGF MET AKT signaling pathway. That means this right here. As you can see, the MET is over here. HGF basically means hepatocyte growth factor. So that growth factor binds to the MET receptor right here. So you can cite the MET as a hepatocyte growth factor receptor, which is basically the definition. MET is also called hepatocyte growth factor receptor. So that basically means, so when you compare it back to figure 1 right here, uh, so basically the HGF goes to the MET, activates MET, and what MET does after phosphorylating, because it's a growth factor receptor and also a tyrosine kinase, it activates the PI3 kinase through binding through the SH2 region of the P85. So after PI3 kinase is activated over here, it basically goes and converts PIP2 to PIP3, and conversion to PIP3 causes AKT over here. I know it says PKB, but protein kinase B is AKT. AKT gets phosphorylated by PDK because there's more PIP3, and that was because of the PI3 kinase. And then you can see over here that basically AKT goes into a whole bunch of actions, most of them relating to cell growth. So phosphorylated AKT, or when AKT goes active, the cell basically goes into a growth phase kind of. It's a growth helper, it's not a growth inhibitor. So back to the figures right here. You can see over here, so the first graph examines the amount of HGF in these cells, or in the sample. The amount of HGF is relatively low in the sorafenib and the sorafenib plus the regular exosomes, but there's a much higher amount in the 97L exosome sample and the 97H exosome sample. And remember, this is in the presence of sorafenib also, so that just shows a higher amount of HGF, which would imply that the HGF PI3 kinase AKT pathway is even more activated. So the first Western blot we have over here, it shows that there is a higher amount of, it shows basically a higher amount of phosphorylated MET, so phosphorylated receptor active in the 97H exosome sorafenib lane. So that basically means that there's a higher amount of phosphorylated MET in the presence of sorafenib and the 97H exosomes when compared to just sorafenib. So if you compare these two right here, there's a higher amount in the 97H exosomes. So that implies the 97H exosome is basically activating the MET AKT pathway. And so although this is supposed to be higher, it doesn't show it well in this lane, but you can see it over here. So sorafenib over here, you can see the phosphorylated AKT. The phosphorylated AKT increases a lot when it's exposed over here to the 97L and the 97H exosomes from the hepatocellular carcinoma. So they're increased a lot. That implies, compared to just sorafenib, so this is less, but this is more, and this is more. This shows there's more phosphorylated AKT when there's 97H and 97L exosomes. So that implies that these exosomes, they're helping activate the AKT pathway, and that's how they're inhibiting. This doesn't actually imply that, but that's basically how they're inhibiting sorafenib. They're activating that growth pathway, and that inhibits the apoptotic actions of sorafenib. That's why over here in sorafenib, there's less AKT, or phosphorylated AKT, that means activated AKT. But over here, with the exosomes, there's way more. And also, regular AKT stays the same, and regular met, non-phosphorylated met stays the same. Over here, though, you can see the vascular endothelial growth factor receptor, VEG, VEGFR receptor, phosphorylated VEGFR, is increased in the presence of the two exosomes also. And this relates to a point they said earlier in the paper where they showed that the exosomes were basically helping angiogenesis and tumor growth through the VEGFR2. But yeah, as you can see here, when there's just sorafenib, this is inhibited, but when basically when you add the exosomes, it's less inhibited. So this is more activated in the presence of the exosomes. Next,